Howdy folks, and welcome to an introduction to Ocaml Day 1, where we're going to go over some basic syntax of functional programming, specifically in the context of Ocaml. Hopefully you're approaching this as if you've had some previous experience with other languages. If not, then I would recommend perhaps starting with another language, because functional programming can get a little funky and weird, but hopefully you know some stuff like basic data types, some basic data structures like lists, and just have a general overall idea of different things like that. And if you don't, I would recommend looking at other videos or just trying to kind of stay along or look up those ideas as needed when we go over them. So, to get into the business of Ocaml now. So, first things first, Ocaml is a great general use programming language. We've got the general here, and basically there's a few different things or reasons why Ocaml is a great general use programming language, and that's because one of the reasons is that you can compile on both the command line and you can use the REPL, and the REPL stands for read, eval, print loops, and it's a very high level language, Ocaml is. So even higher than Java, C#, this is a very high level language that's also very fast and has some really awesome functionality, but it's got a much different layout than previous languages as it is functional and not object oriented. So for those folks that are coming from object oriented language, things are going to get weird, but the idea is going to remain kind of somewhat the same. So we'll kind of go along with that and approach it and try to kind of dissect the differences. So let me tell you about Ocaml in a brief slide, and I've highlighted those as you may see later. And that is that Ocaml supports type inference and type checking. So the compiler's doing all the dirty work of figuring out what you want and making sure that it's going to be used right. So the whole idea of declaring data types like int, string, blah, 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 that is going to be done by Ocaml in the large majority of cases. So that's one of the features or the advantages you could say to Ocaml, is that it's pretty smart in that it knows what you want and it knows what it needs to execute a function correctly. And all kinds of data types are supported with different syntax. So that's one of the really cool things about Ocaml. And we'll look at an example of this in the next slide here, where I've kind of run the REPL on a terminal, and you can see basically how it works is that once you have Ocaml installed on your machine, you just type in Ocaml in the command line or terminal, and that will bring up the REPL. And in that REPL, you can do some declarations, some function declarations, and Ocaml will kind of give you some information as to what it's inferring it or what it's reading it as, and it kind of is a really helpful interactive way to program and kind of do some quick programming or quick checking in Ocaml. So as you can see, the first thing that we have is a declaration of x being equal to 5, and Ocaml is going to declare that as an int because it is a whole number, and it's that's usually what ints are dealt with, so it's going to assign an int to that in that instance. You can also see I have a function, so our very first function. So we can wrap it up right here at the end. That's Ocaml. Now, there's a little more to that than just that. But you can see I have something called times 7, and it takes some variable x. And then what it's going to do is it's going to take x and multiply it by 7. So pretty basic. And you can see Ocaml lays it out down there below the val times 7. And it takes an int, and then it's going to return an int. And then that little fun stands for function. So if we try it with times 7 and then pass in 2, we'll get 14, respectfully. It also supports lists, so we've seen lists before in other languages. And here I have a list of strings, and you can see it's a few of my mains. So you can see it will interpret as a string list because it's in quotations. So that's usually what strings are associated with in most languages. Same thing applies for Ocaml. It also supports tuples. So I've got a tuple of strings, in this case, of two different tanks, Roadhog and Diva, and it's going to interpret that as two strings in that tuple. So all is good there. And then we can get even crazier, and we can support a list of tuples. So we've got this respectfully named list, game-losing characters. These are the characters that people usually switch to that usually end up losing the game for the team because they promise they can play it very well. But I guess that's neither here nor there. But there that is. So you can see again, it's going to find that it's a string, it's stringed tuples, and it's going to be in a list. So you can see that it kind of picks that up right there. Then we have another function, add 8, that has some variable z, and then it's going to take that variable z and add 8. So we'll do an add 8 of 7, and we'll get an int back of 15. And then we're going to get into an error here when we pass in a string, which is not the correct data type for this function. And Ocaml is going to say, F off. You're giving me something that I was not expecting. I did not want that. So here's what I wanted, and I'm just not going to run. So you can see that happens right there when I pass in these nuts. And unfortunately, there's no got 'em failsafe. So it's just going to return an error instead. And that error, as it's seen there, says that it has a type string, but it expected type int. And then at the very end there, we just stop the REPL and finish things off. So that's just a little quick example of some interaction in the REPL and kind of making some very basic functions and variable declarations. So you've seen this let in stuff a lot, so it probably would perhaps help to define these keywords. So the let keyword will bound a name to a value, so very much like variables would bound some name to some value in other languages. That's what the let business is doing in this situation. However, the let also can be used for functions. And when we do that, whether it is a function or it's just some variable declaration, we typically end the declaration with 2 semicolons as opposed to the original 1 semicolon that you might have seen in C or C# or Java. So a little different in that aspect. And then if we're going to make a function out of our let value, we're going to need to use this keyword in some cases. So if we're going to declare more stuff, or if we're going to use more stuff in a function, we're going to use in to kind of separate that stuff. So in also becomes important. As we'll see on the next slide here, that kind of shows some examples of using let and let in. And you'll see that right here. So we have this variable example, and we say let example equal, and then we're going to declare 2 little variables, a and b, but we need to use this in business to say, hey, we want to use these variables, but we're not done yet with declaring what example is going to be. So example is going to use a and b to get its own value. So we can't just end things off with a double semicolon because that ends the example. So we want to continue things going and continue to march through. So that's what the in business is going to do for us. And as you can see here, a is going to equal 42, b is equal to 7. And if we do a plus 2 times b, that's going to be what example is going to be set to. So it will have 42 and 7 saved, and then it will use that to calculate example. And it looks really weird because typically in object-oriented languages, we'd have this function specifically set. You know, we'd say int a equals 42, int b equals 47, and then int c equals a plus 2 times b. But it's kind of a little different in functional programming. But you can see the result is still to be expected as multiplication comes first. 7 times 2 will be done, which will get us 14. Add that to 42, and we've got our 56, which we see down there. In another example, we do some string concatenation. So we've got some string a and a dash, and then we've got another string, amazing. And if we concatenate those together, you'll see another example is going to be set to amazing. Another Overwatch reference for those folks who don't know. And then we've got another, one more little function down there, local. And we've got x and y, x set to 7 and y set to 8. And then we're going to add x and y, so we'd expect local to be 15. And as you can see, what we can do below is once we finish defining local, we can ask the REPL for local again by typing in local and then 2 semicolons to end that line. Press enter and it will give us the value of local. However, if I want to get the value of x and y, those are local to local, which is kind of weird to say, but basically the local scope of x and y is such a case that we can't reference it outside of the local function. So local to local, they can't be referenced outside of local. If that hopefully that kind of helps. That was kind of my thought process, but maybe that was a little confusing. But anyways, the idea is that anything inside that main function or that main declaration can't be referenced outside of that function. So that's why x and y are unbound in this case. So then some other basic syntax in Ocaml. Comments are made using a parenthesis and a star. Linked lists are available and do exist in Ocaml, and we've seen a little bit on them previously, but in case you didn't see the syntax, it's using square brackets and then semicolons to separate the values in between. But you can see we've got 1, 2, 3, and 4, or we've got strings, so it supports all different data types, and of course it's ended by those double semicolons at the end. But then we've also got arrays. Arrays are still in the whole business there, but they look a little more funky in Ocaml, and we won't use them a terribly large amount, but they do exist, so it's good to show that they do exist with some square brackets and a vertical line. That's how we determine arrays, and again, separating them using some semicolon business, but you can see that there. And then also, the string of hello. So of course, strings are always an array of characters, and that holds true in Ocaml. So we've got 5 characters there. So we've got a 5-character array technically in Ocaml for a string. And then finally tuples, which we've seen a little bit in the past. So tuples still do exist, and they are still thriving strong in Ocaml. And you can see here I've got a tuple with a double and a string. So that will be great for hash tables or key value bindings in a search tree. So they do still exist, and they still serve a strong purpose in Ocaml. But that's tuples. So now try some stuff for yourself. So once you've got Ocaml installed on your machine, whether it's Windows or Ubuntu, or Linux, it doesn't have to be Ubuntu, I suppose, or Mac, try the REPL out. So use the command line or your terminal, type in Ocaml, and then try creating a variable x that's equal to 7. After that, try to create a function that would take 2 arguments and add them together, and call that function add2. And then try to create a function called concat that concatenates 2 local strings inside of a function. So kind of make your first little function that has some local reference or some local values inside of it. So then some quick review. So you're still some recruits in terms of Ocaml, but we hope that by the end of these videos, or as you watch these videos, you'll get a stronger understanding of the Ocaml language and become more comfortable with it. So to make sure that you're kind of following along and make sure everything goes well, make sure you can answer these questions. So do you have a basic understanding of how let and in works, what their reasoning is, and how they work as keywords in Ocaml? How would you create a list, or how would you create an array in Ocaml? Can you reference a local variable outside of a function? And then finally, do you have to declare a data type in Ocaml, or does it do the dirty work for you? Hopefully you can answer those after watching this video. If not, go back and check out the video. All these are answered in this video. But anyways, I hope you've learned a little bit about the basic syntax, and if you got any questions, be sure to leave a comment, and we'll see you in the next video.